Welcome to the Safety Artisan. I'm Simon Danucci, and I've been a safety engineer and consultant for over 20 years now. So when I decided to start my own business, I was wondering what I was going to call it. And I looked around at various names, some of which were already taken, and I came up with the name The Safety Artisan for the business and the website safetyartisan.com if you want to take a look. And I came up with that name because I liked the word artisan and what it meant and the connotations. So first of all, artisan means a skilled person who does something by hand. And it can also refer to a thing that is, specially handmade, usually with high quality materials. So I like the sound of that. And I think it's appropriate, even in this modern age where I've worked on, huge projects, multi-billion-dollar projects that lasted for years and involved thousands of people. Because even on a big project, we're still relying on individuals being competent to do a job and to know how to do it, and to have that skill and that awareness and that understanding. So that artisanship, that appealed to me. I thought that's good. And another thing was that there's this connotation of somebody working alone at home, maybe a sort of a cottage industry type setup that used to exist before the Industrial Revolution. Or I should say, before the first Industrial Revolution. Now, whichever Industrial Revolution we're currently in at the moment, I don't know. But we've gone back to a world where, thanks to the internet, you can sit at home and do work. And in fact, thanks to, the recent global pandemic, more and more of us have been sat at home doing work, working remotely over the internet. And I, as an individual, can reach hundreds, thousands, or even millions of people over the internet with my teaching and with my knowledge and experience. So, the internet has really enabled a return to those kind of cottage industry ideals where individual people can do something of high quality and find a market for what they're doing, regardless of, big brand, big business, etc., etc. So we can, you and I can communicate one-to-one or one-to-many, and you can communicate with me, and we can learn together and share together what we want to do. Now, if that sounds good to you, if that sounds something that you're interested in, then please check out the videos and other learning products at safetyartisan.com. And you'll also find me, Simon Danucci, on udemy.com. So if you want to see what I do on a third-party platform, and then that's there too. Okay, well, thanks very much. And I look forward to seeing you again soon. Cheers. Right. Hello, everyone. Well, that's enough of that. That was my introduction by Ed Sheeran. Thank you very much, Ed. And welcome to the Safety Artisan. And today we're going to be having a webinar, which I hope you're expecting, about OSHA and HHA. And we'll find out what OSHA and HHA are in just a moment. So I'm just going to start my presentation for you. Let's get back here. And excuse me a sec. So I'm born in England. I can't function without a cup of tea. So not sure who we've got on yet. I can't always tell. So welcome if you're with the Eventbrite. If you bought a ticket with Eventbrite for nothing, by the way, then wonderful to see you. If you are with me on Facebook or LinkedIn or any of the other social media platforms, then you're equally welcome. So let's get started. I'm going to share my screen. By the way, before we get fully started, can I just make sure, can you all hear me? Can you send me a message if you can hear me? We'll see who we've got. So I'm just going to share my screen. Okay, I'm going to share. There we go. Okay, so let us swap over. Okay, so here's what we're going to do today. Workplace hazard analysis, which we're going to be looking at tasks 206 and 207 of MIL Standard 882E. As it says, it's a free webinar from the Safety Artisan. In fact, just a sec, before we go any further, I'm just going to double check. Oh, brilliant. Thank you very much, Harry. That's good. I did a webinar once where half of it, nobody could hear a thing because I hadn't checked my settings. So thank you very much, Harry. I'm glad you can hear me. Right, let's go back to sharing the screen. Okay. So we're going to be talking this morning about workplace hazard analysis. Now, all of the tasks in MIL Standard 882E, that's System Safety Engineering, all of the 200 series analysis tasks will impact the workplace in some way because they're analyzing the system that we're going to be using, that the workers, the end users are going to be using. But tasks 206 and 207 in particular are all about looking at workplace effects. So we'll get on to that. So first of all, a quick word about myself. Why should you be listening to me at all? You know, what background, what pedigree have I got to talk to you about safety? So I've been in the business a long time, as it says, 25 years. And I've worked on a lot of different stuff, lots of different aircraft. I did 20 years in the Air Force. And so I've worked on fast jets, transport aircraft, reconnaissance aircraft, helicopters, no drones, but lots of different aircraft, surface ships, submarines, air traffic management systems, and a little bit of trains and road vehicles, not much, but software for years and years. So software in all of these things, or considering them. And I've worked on some really small programs, which is lovely. Really enjoy working on small programs where one person can do everything. But I've also worked on some gigantic programs as well. So Eurofighter Typhoon, for example, and the Australian Future Submarine. And as some of you may know, Future Submarine program failed. So I'm here to bring you my experience of things going wrong and learning from that, as well as things going right, okay, which I think is important, because nothing goes right all the time. We shouldn't pretend it does. And in terms of where I've worked, as you can probably tell from my accent, I'm from the UK. I've worked in the UK for many years, and I've been working in Australia on system safety for more than 10 years now. And I've worked on a large number of US and European programs. So in terms of teaching, I've been very privileged to teach hundreds of Ministry of Defence people safety,
because I was on the team that had the contract. And I've now got more than 3,000 students online. So very happy about that. That's lovely. I love reaching out to people. As I said in the introduction, it's great that we can all sit here at home and do this like a little high-tech cottage industry. I think that's a wonderful anachronism, but fun nevertheless. Yeah, and I've got to present various safety topics at conferences. So that's enough about me. Let's move on. Okay, so how do we do workplace hazard analysis? So first of all, we need to just mention that there's, if you like, there's analysis at the workplace, and then there's analysis of the workplace, the future workplace, during acquisition when we're buying or developing a system. So first of all, the workplace analysis. There are two very common types of analysis that you will see around the world. And so the first one is job safety analysis, which is a process that you can apply, as it suggests, to any job that you're doing. So before you start doing a job, you sort of think, oh, well, what are the risks here? What could go wrong? How do we, manage that? And so there's a link there to the Canadian OHS people that have got an explanation about JSA. And all these links, by the way, are in the text. They're all in the chat. If for any reason you can't access those, then send me a message, please, on social media. I'll share the links on social media anyway. Then secondly, for more involved analysis, there's a tool called a safe work method statement. And certainly in Australia, this is meant for high risk work. So it's actually a legislative requirement that if you're doing high risk work, you should use a safe work method statement. And if you go to the Safe Work Australia website, in the link there and in the chat is a link to an example safe work method statement. And if we have time, we'll look at those examples later. And by the way, wherever you are, I highly recommend Safe Work Australia website because it's a treasure trove of really high quality resources and really readable stuff. Very well written stuff. So even if English is not your first language, you'll find some really useful and readable stuff there. So really accessible. So that's doing stuff at the workplace when you're a worker, an end user. But I'm going to spend most of my slides today talking about the other stuff, which is acquisition analysis of work on a system. Okay, so we're going to talk about workplace analysis later, don't worry. But for now, I'm going to talk about this acquisition approach where I assume that we're working on a system, maybe a piece of military equipment, but it may not be because you'll find similar standards for everything. So there's two tasks we're going to look at. So 206 is operating and support analysis, or OSHA, not to be confused with the US regulator of workplace health and safety. And then task 207 is health hazard analysis, which, as it implies, is looking at all things that could hurt people. And actually, these two tasks fit in also nicely with the environmental hazard analysis task, which is task 210, because they're all looking at things that can hurt people or the environment or other animals. So they all fit together really well. But we're not going to be talking about environmental hazard analysis today, just these two safety things. So our focus is on hurting people, or not hurting people, sorry. So let's look at OSHA Task 206, and I'll let you read that. So this is a quotation taken from the standard. And the purpose of it is to, as it says, identify and assess, evaluate hazards introduced by those operating and support activities. Okay, so we've got people doing stuff with the system. What hazards could arise from that? And secondly, we have to evaluate the adequacy of those things that we put in place to mitigate those risks, to control those hazards. Okay, so whether it be procedures, facilities, processes, or other equipment that we've got, safety equipment maybe, personal protective equipment, whatever it might be, we need to assess how effective those are in the context of doing the O&S work. Okay, so very important task, can be a very involved task, as we'll see in a moment. So I'm not going to go into a huge bunch of depth about the OSHA task today. If you want that, then there's an OSHA lesson and there's an HHA lesson as well. And you can buy individual lessons or you can go for a bundle of lessons. So this is just a taster, but I'm using slides from the actual lesson. Okay, so I picked out a couple of comment slides in terms of adding value. Okay, so a couple of hints and tips about using Task 206. As I say, we haven't got time to go all the way through Task 206 in this webinar, but if you are using it, it can be very, very important. These days, a lot of the time, we are not developing new systems. We're either buying a legacy system from somewhere else and using it, or we're buying something that's off the shelf, commercial off the shelf, or military or government off the shelf. Now, in which case, we may not have any access to design information whatsoever. Okay, so we're very, very dependent on just looking at the system that we've got almost as a black box and saying, okay, OSHA, what are we going to do with it? What to operate it and to support it? What's going to be involved? And so this task takes on enormous significance because it might be the only in-depth safety analysis work we can do at all. Okay, so task 206 is going to be very important for these kind of systems. And it's still worth mentioning, by the way, if you saw, I've done earlier webinars on the earlier tasks, you still, even if you've got a legacy or COTS system, we still need to do those initial 3 tasks. We need to do the preliminary hazard identification, where we generate a hazard list. That's task 201. We need to do task 202, which is preliminary hazard analysis. And we need to do task 203, which is system requirements hazard analysis. And I think the webinar that I did on those 3 tasks together is still available online. We'll talk about that later. So we still need to do the basics, but then task 206 is going to be enormously important if we don't have any design information. Second point to notice with task 206 is that the danger is you can analyze everything to death, okay? And on a complex system, you can spend endless amounts of money on this, going into vast amounts of detail. So the way to avoid doing that and spending lots of money to not get much back, first of all, we often need to prioritize OSHA work, okay? And as it says, if we can use other hazard analysis, remember 201, 202, 203, if we can use those other earlier, much cheaper and quicker hazard analysis techniques to identify the biggest risks, we can prioritize those and say, okay, what's the real risks with these systems? Maybe I've got some really nasty chemicals in it. Maybe there's moving parts where people can get their hands or fingers crushed. Maybe there's radiation or heat or lasers or whatever it might be. More on that later. So we can prioritize and apply the OSHA proportionately to get the results that we need to understand the risks. Okay, whereas maybe for some more mundane tasks where really the risks are sort of cuts and grazes and, you know, people falling over when they're not working at height or stuff like that, maybe stuff that isn't quite so serious, we do less work there, or none at all maybe. The other thing we can do is recognize that we don't have to analyze everything. Okay, very often our industry, whichever industry we're in, has developed standard approaches to doing certain kinds of work. Okay, so there's nothing to stop us taking those standard approaches if they're appropriate and just go, okay, we won't bother doing any hazard analysis for this task because there's a standard way of work of doing this in the industry, okay, or that we know about. We'll just apply that to get the safe results. Don't need to spend any money on analysis. Okay. Now I know that sounds like the opposite that a safety engineer should be saying, but we don't want to be doing analysis for the sake of it because it's a waste of time, it's a waste of money, and it brings safety into disrepute. Okay, so if people see that we're spending lots of their money for no real benefit, they're not going to like that, and then they're not going to listen to us. So when we want to talk about something that really is important, we may not get listened to. So we've always got to think about delivering benefit, value for money for our end users and our customers or the organization we work for. And applying safety proportionately and sensibly is, and is essential to doing that. Okay, so that's a little bit about OSHA or OSHA. Let's move on to health hazard analysis. And again, this is a quote from the standard from 882E. And as it says, we identify human health hazards, we evaluate hazardous materials and processes that are proposed for the system, and we propose measures to eliminate the hazards or reduce the risks if we can't eliminate the hazards. Okay, and very often we cannot eliminate the hazards. Now, again, I don't have time because it's a full HHA is a big subject, and I think this is the lesson I do on Task 207 is almost a full hour. In fact, it might be more than an hour because it is such a big, complex subject. So we don't have time for that here. I've just got a couple of slides to help you. But that's basically what we're trying to do. So as I said, I've just said all of this, the lesson is long. There's a lot of stuff in health hazard analysis. So there's hazardous materials or hazardous chemicals, HazChem, whatever you want to call it. There's ergonomics. So we're thinking about, first of all, anthropometrics, which is, how tall or short or how far can a human reach? The size of human beings, do they fit in the vehicle? Can they reach all the controls? Can they reach up to do the work that in maintenance or whatever that's required? So there's the anthropometrics, which is, the size of people, and people do vary in size quite dramatically. And then secondly, there's the wider ergonomics of, repetitive strain injury, musculoskeletal disorders, where we're asking people to move stuff or twist or stretch, and people can hurt themselves doing that, or trying to get into very hard to access spaces. Okay, so we can introduce hazards by having hard to access or hard to work on places. And I've certainly seen, plenty of that in my career in the Air Force. There was an infamous area inside a Tornado aircraft called Zone 19, and it was the ground crew, to do any work in there, had to remove a piece of equipment, and then you stood up inside this thing, which was pitch black. You couldn't see a thing, and there was no lighting. And then in order to do certain jobs, the ground crew actually had to stand up and do the job over their shoulder. So using a screwdriver and stuff to fix stuff behind them in the dark, because there was no room to do anything else. You couldn't actually work like that. There just wasn't enough room in zone 19. So they had to do all the work like that, which was crazy, as you can imagine. They eliminated that zone in later designs of the aircraft. But so you can have some weird stuff in terms of access. So we also think about the operating environment. So we might be in a cold environment, wet, windy, hot and dry, dusty, and also for the military, of course, they will be thinking about nuclear, biological, and chemical contamination. So, do people have to work in protective gear, whatever that might be? And of course, if it's very hot and you're wearing protective gear, fatigue is going to set in very quickly. And again, having done this, it can be very, very unpleasant. So we shouldn't be asking people to work for a long time in heat in that gear. And then finally, of course, radiation. So whether that be non-ionizing radiation, so radio frequency, radars, radios, etc., or it could be ionizing radiation. Maybe we've got a radioactive source. And we have radioactive sources, small ones, in smoke detectors, but they're also used industrially for all sorts of reasons. Okay, so we can have, and so electrical switchgear can emit X-rays and things like this. Okay, so there's a wide range of radiation that we might have to deal with, and of course, people fear and dread radiation because we can't sense it. So that's always going to be a very sensitive topic. And there are very strict rules about managing radiation. So we've got to know our stuff. We've got to know what the regulations are and follow them very closely. Okay. And there's more stuff in the full lesson than this, but I just picked those ones out. So a couple of slides of commentary or advice. The first thing to note is because 882 is a US standard, it's written with US legal requirements and legal framework in mind. Okay, now that's complex in the US because the US is a federal state, so some things are ruled by the federal government, but a lot of health and safety stuff is ruled by state and territory, or state government, sorry, in the US. It's similar in Australia. We have a federal government and we have states and territories which are somewhat independent, and they can make their own rules, which can be, or vary the rules, which can be different. I mean, we're lucky in Australia in that we have WHS, we have workplace health and safety, which is a standardized approach to health and safety in Australia, and very, very useful, very clear and easy to read. So if you're whichever jurisdiction you're in, you're going to need to tailor Task 207 to suit the jurisdiction and the rules that you've got to obey. And the process by which you do that is you do Task 203. Remember, the safety requirements, system requirements, hazard analysis. So not only do you look at the requirements for the system in that task, you look at your legal requirements and all the regulations and standards that you may have to apply. So that's why you still need to do Task 203. Okay. Now, if you're in a country where the rules are lax or don't exist, you could do much worse than looking at Australian WHS, because there's a lot of good common sense stuff in there. And there's a lot of free resources at Safe Work Australia. Okay, so if you're not sure what to do, if you've got latitude, wriggle room in what you do, but you want to do something good, then I would recommend going and having a look at Safe Work Australia, and you'll get lots of good guidance there, whether you are obliged to do it in your country or not. Okay. So, and as it says, tailoring those requirements to the local jurisdiction will be crucial to achieving compliance with local regulations, whatever they may be. So I spend a lot of time in the lesson commenting on tailoring for WHS and other jurisdictions. So that's that one. So just the second one. Again, we need to set scope and priorities, because if you go into this and just go, I'm going to do everything to an equal depth, you're going to spend a lot of money, and you're probably going to waste a lot of money and a lot of time, and which will not make you popular. So as another reminder, we still need to do those first 3 quick, cheap tasks in order to understand our priorities. So advice here, some of this work can be quite specialized. So either, yes, we can read the books and we can learn how to do it and we can do the work, but it will probably require quite an investment in time to do that. Okay, so be ready for the more specialist stuff, maybe the radiation stuff or whatever it might be in your area. Maybe there's a particularly demanding thing that you've discovered. Maybe you get somebody, a specialist, in to do that work. They may cost a lot of money, but they're probably going to do the job a lot quicker. Second thing to say is it's very easy to get worried about certain things, okay? Particularly some hazardous chemicals. So people get very worried about lead, like, lead solder or asbestos or cadmium, chromium, those sorts of things, okay? And there's a good reason for that. And certainly in Australia, the Australian Department of Defence is absolutely paranoid about hazardous chemicals, because we had a HazChem scandal some years ago where several hundred defence workers were, poisoned with hazardous chemicals, and it affected their health quite badly in some cases. So that was a big scandal, and as a result, the Department of Defence here is very switched on, very hot on this topic. However, we have to remember that even if we have got these nasties present in our system, there's actually got to be a path for the nasties to get to a human being, and often for the human being to either breathe them in or eat them or get them in a cut or something in order to be poisoned or to be affected. Okay, so there's got to be a credible exposure path to for anybody to get hurt. Okay, so the top tip here is don't go overboard just because you've got a hazardous chemical present in the system. Look at, is there actually a way that this stuff could hurt somebody, could get to a person, hurt them? And if there isn't, so we've got cadmium plated connectors in a lot of US sourced electronics because it's still perfectly legal there. But the reality is there's very little cadmium. It's locked away inside an electronic box, and actually you'd have to eat it or slash yourself with it to get it into your system in order to hurt you. So it's not going to happen, okay, in normal business. Whereas there's some other things where if you've got the starter system on I think an F-16 is you start the engine with something called hydrazine, which is a very dangerous and volatile substance. And because it's a liquid, you've got to, the ground crew have got to handle it. They've got to top up the hydrazine tank on the aircraft, etc., etc., and it produces noxious gases, etc. So there is a credible exposure path there. People have got to handle this stuff. They could get hurt. So as an example, that's something you would spend a lot of time working on, making sure that you had adequate procedures and protective gear for your maintenance staff to be able to handle that kind of thing, because there is a credible exposure path. Okay. The other thing to remember is that in normal use, most of the nasties are locked away and they're quite safe. But if there's been an accident or some sort of damage to your system, or it's caught fire, that can change everything. Fire, especially, the high energy exposure can change chemical compounds, produce gases and smoke and particles. It can change even relatively harmless stable chemical compounds into something much nastier. So think about that. Okay, what's a credible damage or accident scenario? Do we, if we're cleaning up an accident, do we need to take extra precautions, and therefore do we need to buy some stuff in advance? Our emergency preparedness, do we need to be able to cope with hazardous materials at the crash site or at the accident site or after the fire, and cleaning up as well? Okay, do we need, do people need to wear breathing protection or a hazmat suit or whatever it might be? So do think about those things. They happen, obviously, we hope very rarely, but they can be very, very serious. And that's often when the hazardous chemicals can really get exposed to people. So there's some words about those two tasks, which I hope you found useful. So next steps, I've got a few resources to help you, and all of these links are in the chat, by the way. So there's a number of stuff. If you go to, I'll tell you the website in a moment. You can get a free preliminary hazard identification and analysis guide, which I produced. I've just done a new free download on system safety concepts and principles, which is it's a couple of videos and some resources there. And you can get email notification about all of these things by subscribing for free to the Safety Artisan. And again, follow the link in the chat. And or you can go to the website www.safetyartisan.com, and there's lots of free resources on the website, and there's paid lessons and whole courses as well. So you can get, so I've talked about tasks 201, 202, 203, 206 and 207. You can get any one of those lessons on its own for $45 US, or you can get bundles at a further discount. Okay, and in fact, if you go and subscribe for free for the emails, you will get much bigger discounts. You'll get a 60% discount on most of the courses on the website. Okay, so a big discount available. Subscription is free, and also I'll keep you updated on what's coming up and what's new and what comes out. So a little plug there. So lots of resources for you there at the Safety Artisan. So I just wanted to say we have got some time left, so we will look at some further things. The next one, this is part of a series of webinars. The final webinar in this series is next month in July. Hazard analysis within systems engineering. And I'll be doing that it's the 12th of July if you're in the US, and the 13th pretty much everywhere else. So I say the US, North and South America, Central America, it'll be the 12th. It's the 13th of July everywhere else. And I will be looking at tasks 204, 205 and 209. So that's subsystem, system, and system of systems hazard analysis. Okay, so we will look at all of those things, and we will look at them within the framework of systems engineering. Okay, now all of MIL Standard 882E is designed to work within systems engineering. That's why it's called system safety. But those three tasks especially fit very closely with the specification and testing requirements and testing process that's built in to the systems engineering V model or any other systems engineering model that you want to use. So we think very much about the front end of, as we decompose the system, we think about the requirements that we need to meet. And then on the right-hand side of the V, we think about verifying those requirements and ultimately validating the entire system or system of systems. Okay, so those three tasks, 204, 205, and 209, are really going to help us with the safety of highly complex systems. And I've done this type of work for real, and it's challenging, but it's very, very interesting and exciting work to do. So I'll share some of that with you, I hope. Okay, so we're going to break now for questions and answers. And it says ask me anything within, well, you can ask me anything. I might not know the answer. So we're going to do some questions and answers now. And let me get back to, there we go. So we have got an opportunity now. So feel free if you've got any questions on those. What is my system? No, stop that. Right. No, go away. Sorry about that. That's Windows playing up. Right. So right, I've got rid of that. Right, sorry about that. So have you got any questions about what we've just talked about? So if you're on Greg, I think you can send me a question in the private chat. And Harry and everybody else who's online. You should be able to send me a question. Chat. If you can't for any reason, I think if you're on Facebook and YouTube, you're okay. I'm not sure what's going on with LinkedIn. We are there on LinkedIn. If you can't send me a question, then by all means send me a question through social media or go to the website. And if you go to the contact page, you can leave a comment on anything content on the website, or you can send me a question by submitting a form and I'll get back to you. And that will come through to my email and I'll send you an email reply. So any questions at all? Okay, well, I'll let you have a think about that. So what we'll do then is we'll move on and I will go back to sharing my screen. So if we move on, I mentioned that we would have a quick look at these two techniques, job safety analysis and the safe work method statement. Now, if we look at these things, okay, so here we are, we're on the job safety analysis page, as you can see, for the Canadian Centre for OHS. Very good. And let's start. As it says, job safety analysis is a procedure which helps us integrate health and safety into a particular task or job operation. Okay. And you can expand this JSA or job hazard analysis, sometimes you'll see it called that, to everything, not just safety, and think about what are the different aspects. So the trick with a JSA is to break the job down into appropriate chunks. So on the one hand, too big a chunk, if you say, as it says, if you define too broadly, I need to overhaul an engine, well, that's a big piece of work with lots and lots of steps within it. So just thinking about overhauling an engine, you'll get some top level stop, but not too much. But if you go too narrow, for example, say, putting a single screw in or a single fastener or positioning a car jack, that's probably too low a level. So we need to find that sweet spot between, a big job that's all encapsulated, can't really see it, to too many little jobs where it's going to take up a lot of time to analyze that for not a lot of benefit. So really, we need to take that big job and break it down into some sort of medium-sized chunks, and then think about, well, what are the hazards with this chunk and that chunk? Maybe gaining access, taking it apart. I say gaining access and making it safe before we start work. All the way through the job to putting it back together again, testing it, and then making it safe to use. Okay. And restoring it to operation. So the trick with JSA is to get that appropriate level of granularity. And so, and as it says, we've got 4 basic steps: selecting the job, which we've talked about, breaking the job down into a sequence of reasonably sized steps, identifying the hazards, and then determining controls. Okay, so it's pretty, there's nothing that dramatic about JSA. It's just, the application of some structured common sense, I would say, which, to be fair, a lot of safety engineering is just structured common sense. And so there's some more details here on doing a JSA. And the Canadian website is pretty good. There's lots of good information on here. And as you can see here, we've got some example forms for you to use. Okay. So that is JSA. Let's go back. Now let's talk about safe work method statements. Now, certainly in Australia, using safe work method statements is mandatory for high-risk work. Okay, and we'll see what high-risk work is in just a moment. Now, it says it's not a procedure, it's a tool. But to be honest, it is a procedure. It's just a bit fancier and a bit more complicated than a JSA. All right, that's all. So here we go. So this is one of the information, or one of many information sheets on the Safe Work Australia website. And so it talks about what is an SMS, what do I do, who should prepare it. It's using the idea of principal contractor in construction. Okay, this is an example for construction. So forget the principal contractor. That's a concept that's in construction law in Australia. There are many other examples of this that are not necessarily construction. Okay, but SWIMS is mandated for high risk construction work because it is high risk. Let me just turn this round. There we go. So I'll just make this a bit bigger. So here's a great example. Forget that the stuff in blue, that's just filling in the form. What we're really interested in is these boxes here with the little squares, the little tick boxes. So here we've got some examples of high risk work. Okay, so risk of a person falling more than 2 or 3 meters, likely to disturb asbestos, working near a shaft or a trench, working near chemical, fuel or refrigerant lines, okay, and so on. Use of explosives, diving, powered mobile plant, work in a confined space. So all the things here, what have we got here? We've got 18 examples of high risk work here, and they're high risk because lots of people have been killed and injured doing them. So this isn't theoretical. This is very much based on the real world. So straight away, we've got a prompt here. We've got a checklist that's prompting us to say, are you doing any of these things? If you are, you need to continue filling in this form. And we'll come back to who does what. So as it says, what are the tasks involved? What are the hazards and risks? What are the control measures? So at this point, we've gone back to sort of JSA territory. Okay. It's just that we've got a more structured approach, a more formalized approach here, because the risk is higher and therefore that's justified. Okay. So yeah, it's like a sort of souped up JSA. And then it's a legal requirement for all the workers who are going to do this work. They have to have, ideally, they should have been involved in preparing this safe work method statement. But if not, if somebody else has done a generic one and it's the same task or a very similar task, the workers need to be briefed on what's in the safe work method statement. And then they need to sign, as you can see over here, to show that they've been involved. So the legislation actually requires this interaction. So we've actually got recorded who's responsible for assuring compliance, who is responsible for reviewing control measures, how will they be reviewed and when, if this thing is to exist for any length of time. You know, what time, when was these swims created or received? When was it reviewed and who reviewed it? Reviewer's signature. So built into this form is a requirement for people to sign to say named individuals did this assessment, reviewed it, signed and accepted it, and said, you know, I understand this is what I've got to do. Okay, and that is built into the legislation. And then these forms, they become a health and safety record, and it's a legal requirement to keep these records for a certain length of time and to produce them when required, okay, by various parties. So the regulator can demand to see these things, a health and safety at work representative can demand to see these things, etc. And certainly if there's an accident, these records will be seized and used in the investigation. So this is like a JSA, but much more formalized and better structured. Okay, and certainly in Australia, yeah, it's enforced by law. Okay, so and there are rules about, can we use a generic SWS, SWMS? And yes, you can if it's appropriate. But also, you know, there's quite a list of rules about how you do it. So if you encounter something where you start off using a JSA or a JHA and it turns out to be too difficult, you know, it's what you're dealing with is too complex for a JSA, you feel, try a safe work method statement, whether it's mandated or not. You know, there's free, you know, anybody can get online and print this stuff off and use it. And, you know, it's a good idea to do that, I would suggest. Okay, sorry, let's go back to, I'm trying to think. Okay, so I've got to the end of my prepared webinar. We've still got a few minutes left for questions, so I shall just stop sharing. And let's see, do we have any questions on any safety subject at all? Okay, I'm not seeing any in the chat. But I will. Okay. All right. Well, thank you very much, everyone. Thanks for joining in. And I hope you enjoyed this morning's webinar. and it's coming up for 8:30 in the morning here in Australia, and I will be back on doing the same webinar at 5:30 this afternoon or early this evening, whichever you prefer. Okay, so thanks very much, everyone, and I hope you enjoyed it. Thanks very much, Greg. Thank you. I really appreciate your comments, and thank you, everyone who's been online. Okay, I will just to remind you again, if you do have think of any other questions, then please get in touch on social media or on the website. And do please go and make use of those free resources. Okay. Thanks very much, everyone. Bye-bye.